Welcome viewers, in this video we will see the transformer short circuit test. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we will go to the topic transformer short circuit test. So we have two different tests available, open circuit test and short circuit test. Open circuit test available in the different video, separate video, link is available in the description box. This open circuit test and short circuit test is used to find the four parameters: equivalent resistance, equivalent reactance, core loss resistance and reactance, that is R01, X01, R0 and X0. This R0 and X0 no load component is calculated from open circuit test. This equivalent resistance and reactance R01 and X01 is calculated from the short circuit test. So our aim is to find these four parameters in order to draw the equivalent circuit. From the equivalent circuit we can go for further analysis of the transformer. Now we will go to the topic. So we have the primary winding and secondary winding is available. This is the low voltage winding. The low voltage winding is short circuited. The test is performed on the high voltage winding. The short circuit test is performed on high voltage winding and low voltage winding is short circuited. So we have the supply available, phase and neutral, single phase AC supply. It is connected through the DPST switch by the variac. In order to apply the rated voltage, we can vary the voltage by this variac. We have ammeter is available in order to measure the current, and wattmeter available, we can measure the input power, and voltmeter available, we can measure the voltage across the high voltage winding. Now the supply is given by closing the DPST switch. By varying this variac, we can apply the rated current. In open circuit test we applied the rated voltage, primary rated voltage. Now in order to measure the copper loss, we are applying the rated current. By seeing this ammeter, we need to refer the rated current is applied to the transformer. How to measure the rated current we will see by later. So by varying the variac, the rated current is applied to the primary winding. The secondary winding is short circuited. So the applied voltage is very less, but the current is more. The rated current is applied. So the loss happen in the winding is fully the copper loss, because the voltage is very less, the core loss can be neglected. Only we can consider the copper loss. So power measured by this wattmeter is nothing but copper loss reading of the copper loss value. So this ammeter will measure the rated current of the transformer. Voltage meter will measure the voltage across the high voltage winding. This wattmeter measure the input power, that refers only the copper loss, because current is more, so the copper loss also more. Voltage is less, so that we can neglect the iron loss. Now we will see the description so that we can go for more details. So the short circuit test is done on the high voltage side of the transformer. It is called short circuit because the low voltage winding is short circuited. So by using this we are going to measure copper loss R01 and X01 or Z01. R0 and X0 is calculated from open circuit test. So our aim is to find these two values as well as copper loss. So to conduct this test, LV side winding is short circuited. Supply is given to the high voltage winding. So this ammeter, voltmeter and wattmeter are connected to measure the power, voltage and current. The supply is given to the high voltage side, increased until the primary rated current is flowing in the circuit. So because of short circuit test, we need to apply the vary the variac until the primary rated current, rated primary current. In case of open circuit test, we applied primary rated voltage. Now we need to apply primary rated current, rated primary current. How will you find the primary current? I1 equal to kVA rating of the transformer divided by V1, voltage of the primary winding. So kVA divided by V1, we can get the rated primary current. So by varying the variac, we need to apply rated primary current. Now the applied voltage is low. So, the core loss is less, that can be neglected. At the same time, the current is more. So, copper loss will be more. So, the wattmeter reads only the value of copper loss. This iron loss is neglected. Total loss is iron loss plus copper loss. Because of low voltage, iron loss is neglected. Only we can consider the copper loss. So, the wattmeter reading is nothing but the value of the copper loss. So, therefore, wattmeter reading equal to WSC, short circuit power copper loss, that is equal to copper loss. Copper loss is ISC square into R02. This ISC is the short circuit current and this R02 refers the secondary side. So, R02 equal to WSC divided by ISC square. So, our one aim is to find this R02. So, this calculated from the wattmeter reading, the resistance of the transformer, equivalent resistance of the transformer is calculated from this wattmeter reading. R02 equal to WSC divided by ISC square. We assume that only we have copper loss, iron loss is neglected. So, ammeter reading is nothing but a short circuit current ISC, that is equal to I1, rated primary current. Voltmeter reading is nothing but voltage required to drive the rated full load current. This voltage equivalent to the full load current. What is the voltage while applying the full load current? So, VSC. So, this VSC equal to ISC into Z02. Short circuit current voltage equal to short circuit current into Z02. Impedance of the transformer. From that, Z02 equal to VSC by ISC. So, by rearranging we can get. So, this impedance also now calculated. The reactance. So, we calculated the resistance and the impedance. From that we can calculate the reactance. X02. X02 equal to square root of Z02 square minus R02 square. So, we calculated reactance also. So, in this we have ammeter, voltmeter and wattmeter available. Wattmeter refers the copper loss. Input power given to the transformer, we assume that power is equivalent to the copper loss, because iron loss is neglected because of low voltage. Because of high current, we consider only copper loss. And wattmeter and ammeter reads the short circuit current, because we are applying the rated current. So, equivalent to that rated current, the voltmeter reads the short circuit voltage VSC. So, from this VSC, ISC and WSC, we calculated R02. From wattmeter reading, we calculated R02. From this VSC and ISC, we calculated impedance. From impedance, the reactance is calculated. So, by using this, we can draw the equivalent circuit. So, further performance can be analyzed from the equivalent circuit. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.